Hello, this is Stefan from Sintrol. Today I would like to talk about the mechanical installation of our S300 and Snifter series. Safety first. Please be aware that whenever you're approaching your ducts or stacks, there could be poisonous, hot or pressurized gas. So whenever installing or removing our equipment, please follow all applicable local and plant-specific safety codes and wear appropriate protective clothing. Installation location. Please make sure that you install our instrument in a straight piece of duct perpendicular to the flow. We recommend to be about 5 times the diameter away from any bend or diffusers or whatever, upstream, and about 3 times the diameter downstream from the measurement point. Absolutely never install it straight into a bend or right after. The conditions there are so turbulent and foremost they are varying with the air and the flow speed. Now, if you don't have such a long piece of ductwork, make sure that you keep the relation 5/8 to 3/8, meaning you should be always a little bit more away upstream from the last bend than you are downstream. Another important thing is that you use a metal duct to install our sensor. For our measurement, it's essential that we have a Faraday cage around our probe. So only a metal duct will give these conditions. If this is a plastic duct or something else, our measurement most likely will not work. In such cases, you could install here a mesh wire or something just to be, or for small ducts, you could even tape it with a metal tape. Just make sure that we have a Faraday cage just all around our measurement place. Horizontal installation. We recommend to install the sensor always on top or on the sides of the duct. This is the same for square-angled or round ducts. Please don't install it to the bottom, because there we would collect all kind of dirts and maybe also condensation between the socket and the probe. For hot ducts, we recommend a installation on the side so that the air vent, the natural air vent, will cool down our instrument. For installations with very low flow speeds, I would recommend an installation a little bit on the lower side of the duct, as here are all the big and heavy particles. Then the weld socket. Please cut a large enough hole into the duct. Not like here. The hole should be so that it is completely open all to the diameter of the socket. And that would mean you cut about a 35mm hole for the S300 socket and a 22mm hole to the Snifter socket. After that, please weld an airtight welding all around the socket and make sure that it is perpendicular to the flow in the duct. Probe length. For uncritical installations, we recommend the probe to be about 1/4 of the duct, and for more accurate measurements, we recommend a minimum of 1/3 of the duct. However, make sure that your probe never touches the other side of the duct, because that would create a shortcut between the probe and the metal duct. And that would completely distort all our measurements. Then hot ducts. Well, basically, we have two influences. One is the radiation from the hot duct to the body of the sensor, and the other one is the hot gas inside the duct, which mainly affects our Rayton isolator, which is good for about 200, 250 degrees. So to avoid radiation from the hot duct to our instrument, we either recommend at least a heat shield or, better, a completely isolation around the duct. Then I would recommend to retract the instrument from the hot gas to get your Rayton off the hot airflow. That can be done either by installing a flange, like here, or by a longer heat socket from Sintrol, or, as it's displayed here, doing both. If you do that, the insulating material will be retracted from the hot airflow and thus don't get so hot. So with the Sintrol heat socket, we can achieve 300 or 700 degrees depending on the model. Note the probe length. If you retract your probe from the duct, of course the usable probe length is much shorter than it was before. So your probe length may be calculated a bit longer. Condensation at the duct wall. Many processes create wet flue gas and may have the problem that there is condensation towards the walls of your duct. Now, if you have droplets and condensation, first of all, it may accumulate here between the socket and the probe isolator. And second, it could even create a shortcut between the measuring probe and the duct wall, and thus distort our measurement. Therefore, we recommend to install, in such cases, the sensor a little bit downwards, something like 5 degrees, and use Teflon coating. Teflon coating will prevent the shortcut between the probe and the duct wall. Note, Teflon is not allowed in any ATEX applications. You can use our special Salo coat, which is good to 700 degrees Celsius. Another possibility to avoid bridging and bad influences to the measurement is to use an air purge. That can be installed here in between the flange and the instrument. It will dry out the gas and keep the measurement clean. Distance to the electrostatic precipitator. If you are measuring with our instruments after an ESP, you should note that each ESP will create an electrostatic field which may have an influence to our measurement. That field will disappear over the distance. Now, if you have just only one or two bends in between ESP and our measurement, please make sure that you keep a minimum of about 40 meters. If you have a blower in between ESP and our measurement point, that distance decreases a lot to about 20 meters. After that, the electrostatic field of or electromagnetic field of the ESP will be disappeared. Thank you for your attention.